is one of the ways to make permanent joints. Okay, and welding is standardized by the American Welding Society, for which the short is AWS. Okay, and let's just look at this one simple example of a welded joint and how it is expressed in machine drawings. For example, we have a part over here, okay, and to it there is another part welded, which is this one, okay. And if we look at another view of this, it's going to look like this, that this is part 1, okay, welded to this part 2 throughout the circumference. The gray or the blackish drawing that you see, that is the welding done to it. Okay? Now it is represented by this symbol in drawing. This means that this is a fillet weld on the outer side. Okay? So this is the symbol for the fillet weld, and it has a thickness of 5 millimeter, and it is done around the part. Okay? And there is an arrowhead that points to the weld in the drawing. Okay? Now let's see, welded joints have we can do welded joints in many ways, but as I said, that they can be represented with the help of these symbols in a drawing. कि ये जो arrowhead है, it connects to the reference line to the arrow side of the joint, ठीक है जी, to groove members or to both. So with this you represent in a drawing where the joint is.
सर
जी
वो सर एक दोस्त कह रहा है कि वेटिंग फॉर द होस्ट आ रहा है, उसको अलाउ नहीं कर रहे सर, अलाउ कर दे।
मैंने अलाउ किया सर।
ओके सर,
ठीक है जी, अभी तो कोई नहीं।
सर वो नादिर कह रहा था।
नादिर, I don't let's see, where is नादिर? अभी तो कोई वेटिंग में, अभी कोई नहीं है। मैं जो भी
ओके सर, मैं कह देता हूँ सर,
ऐड कर देता हूँ, उसको कहो दोबारा आ जाओ, मैं इन कर दूंगा। अभी हयात है,
ओके सर,
है उसको मैंने इन कर दिया बस, और कोई नहीं है।
ओके सर,
ठीक है, अच्छा जी। So as I said that there is a lot of information that you can include in the drawing. For example, the finish that you would put there, the size and or strength for the resistance weld. Similarly, there can be many process specifications that you would put. Some of the important ones that are the length of the weld, and where the weld is done. These are the most important ones. So have a look at these. Okay? Also, we have a different welded joints. For example, if you look at the types of welds, you can have different grooves. For example, square groove, V groove, bevel, U, J, etc. And the different types that you would use in these is bead, fillet, plug, or slot. So you can represent or you can show these in the symbols that you use in drawing. Okay? Now if you look at these examples यहाँ पे, so let's say this part is welded to this one with a fillet weld, and which is 5 millimeter in size, and it is welded on both sides. देखिए यहाँ पे on one side and then on the other side. So this symbol shows that it is welded on both sides. ठीक है, with 5 millimeter जो है ठीक है. Similarly, इसको अगर आप देखें तो this is an intermittent weld. It means that there is a weld over here, 60 millimeters, and then from this center to this center there is a 200 millimeter distance. It can be shown with this arrowhead. So a fillet weld and a fillet weld. So on one side, and then you have it is intermittent with 620. So this is how it is shown as symbol in the drawing. We just discussed this one in the previous slide. ठीक है. Now, as
सर
जी
सर ये बहुत से स्टूडेंट का ज्वाइन नहीं हो रहा, मैसेजेस कर रहे हैं सर.
यस सर, मुझे भी उनका
so we already discussed these. So again, I would say, but if you look over here, so you would see that this is a square groove, okay, and it is represented over here. Similarly, there are different types of grooves, V groove, and so on. So have a look at them in the figure. Okay. Let's look at the joint and see what are the stress. What is the amount of stress that are acting on the joint? Okay. If you look at this drawing, so there are two parts in here. Okay. And let's have a tensile butt joint over here. Okay, this is these are two parts. If I draw this, so one part joint with another part, and this is the groove. Okay. And then there is basically this is the welding on it. So यहाँ पे अगर आप देखें, so this is the welding on it, and that welding goes all the way to a certain length, where the length is L. Now, so these are the two parts. With force F applied. ठीक है. अच्छा, अगर हम कहें कि the minimum thickness over here is H. ठीक है जी. तो what would be the stress? देखिए इसका एरिया क्या होगा, वेल्डमेंट का एरिया क्या होगा, इस वेल्डमेंट का एरिया क्या होगा, A is equal to H times L. ठीक है, because it has thickness H and the length is L. ठीक है, so we can calculate the normal stress on this weldment, which will be F over HL. ठीक है जी. तो throat H does not include the throat H does not include the extra reinforcement. देखें यहाँ पे अगर आप देखें तो we have this is the minimum throat H, but it does not include this extra जो welding इसके ऊपर, it does not include this extra weld in here or the extra material in here. This is known as reinforcement. This is on this side as well as on this side. We are not including this in the calculation of stress, because that, yes, it does add extra strength to the weldment in static loading conditions. But if we are using this for fatigue loading, then there is stress concentration over here, because there is sudden change in the area. ठीक है जी? So this sudden change in area, um, at this point, then there is stress concentration, and we don't want that in fatigue application. So what we do is we shave this off. हम इसको we grind this off and make the surface flat over here. Okay, Muhammad Hamad, you wanted to say something? Hamad, did you want to say anything?
यस सर
Go
सर
ahead.
ये जो हमने वेल्डिंग किया ये बिल्कुल स्ट्रेट नहीं है तो हम एच ले सकते हैं क्योंकि एच तो स्ट्रेट डायमेंशन है ना
Mm-hmm.
तो सर
What?
एरिया हमने तो वेल्डेड का लेना है ना
Yes. तो इसका एरिया क्या होगा? इसका एरिया तो ये होगा ना कि if we are looking at it from this side, because we are applying force, so basically if this is your plate, ठीक है जी, तो इस प्लेट पे जो वेल्डिंग हुई है वो तो यहाँ पे इसी पे ही हुई है ना, मतलब वेल्डिंग तो हमारे पास यही हुई है ना।
तो सर वो तो प्लेट
तो
का एरिया आ जाएगा ना
मैं बता रहा हूँ ना आपको ये, और इसकी हाइट क्या है? इसकी हाइट क्या है? एच।
एच
और इसकी लेंथ क्या है? ये वाला।
यस सर एल
तो इसका एरिया क्या हो जाएगा?
एच मल्टीप्लाई बाय एल।
हाँ, क्योंकि लोड तो इसी पे ही लगेगा ना, ठीक है जी। समझ आ गई अब?
ओके सर।
ये अलग बात है कि देयर इज सम एक्स्ट्रा इसके ऊपर, वो एक्स्ट्रा ये वाला, ये पोर्शन जो है दैट इज एक्स्ट्रा, बट वी डोंट काउंट दैट, ठीक है। और इवन जब हम फटीग एप्लीकेशन के लिए इसको इस्तेमाल करते हैं तो वी वुड गेट रिड ऑफ दिस, हम इसको जो है वो ग्राइंड कर देंगे और इसको बिल्कुल सरफेस की तरह, सरफेस के साथ एक जितना ही करेंगे, ठीक है जी। अच्छा, ना ये था हमारा स्ट्रेस इन इन नॉर्मल स्ट्रेस जो हमारा था, वो हम शेयर भी हम ले सकते हैं। मींस के अगर हम इस फोर्स की डायरेक्शन को change करें तो again what will be the, now in this case what is going to be the average shear stress F over HL, ठीक है जी। जो H हमारा ये है और L हमारा ये है, ठीक है जी। and again the reinforcement is going to add strength to it, लेकिन हम इसको कैलकुलेशन में नहीं ला रहे हैं because we are talking about the minimum जो हमारे पास थ्रोट हाइट है उसकी बात कर रहे हैं, ठीक है जी। अच्छा, लेट्स कंसिडर अ ट्रांसवर्स फिलेट वेल्ड, ठीक है जी। व्हाट इज ट्रांसवर्स फिलेट वेल्ड? देखिए, लेट्स से कि ये हमारे पास एक प्लेट है जिसकी थिकनेस जो है दैट इज एच, अनदर प्लेट विद थिकनेस एच एंड अनदर प्लेट विद थिकनेस एच, ठीक है जी। तो अगर हम यहाँ पे इफ वी अप्लाई force F, yes, go ahead.
सर मेरे साथ अभी नेट का मसला भी है और इलेक्ट्रिसिटी भी नहीं है सर, ये रिकॉर्डिंग फिर बाद में मिल
लेग तेज खबर रखो बच्चा।
सर जी मातरफ नेट की मसला था, वो बिजली का रहा सर जी।
Okay.
रिकॉर्डिंग
Okay, I have another class tomorrow at 8, ठीक है जी? And there is another class at 2 and another class on Wednesday at 9. You can sit in any of those, ठीक है? अच्छा जी. So if this is a transverse fillet joint, hang on, let me mute everybody. So if you look over here, we have the thickness of these plates as h. ठीक है जी? अच्छा, let's consider this joint over here, yeah, this weldment over here. So if we zoom this, so it's going to look like this. ठीक है जी? तो यहाँ पे if I take, you know, section anywhere, ठीक है जी? It's going to look like this. Now, let's attach some axis over here to this weldment. Let's say कि ये जो है हमारे पास, this is x, ठीक है जी? And this is our y. Now, there are going to be if we are applying force F over here. अच्छा, again, how is it going to look like? मतलब ये तो एक view है ना? What it is going to look like is it's going to be like this, है ना? ये तो ऐसे होगा ना, right? Right? So this is also going to be, you know, I would say rather, with transverse we mean that again यहाँ पे ये, this is the plate, right? And then we have another plate down there, which is this one. ठीक है? So the weld is done over here. मतलब यहाँ पे this is the weld done. ठीक है जी? So this is the fillet weld over here. Now, why do we call it transverse weld? Because the force is applied perpendicular to the weldment. And this weldment is going into the screen.
सर मुझे आवाज नहीं आ रही है सर.
नहीं आ रही है आपको आवाज? हेलो हेलो हेलो
हेलो.
हेलो,
आ रही है सर आवाज.
आ रही है कि नहीं आ रही?
यस सर, आ रही है सर.
आ रही है.
ठीक है जी. So what I was saying is, because the force is applied perpendicular to this weldment, that is why it is transverse. ठीक है जी? Now, अगर आप देखें तो let's see. Now, it will have two components. ठीक है जी? When I apply force, so if there is this plane, so there is going to be one force that is acting normal, ठीक है जी? और उस normal force को हम क्या कह देते हैं? Fn, ठीक है जी? And then there will be one force that is acting parallel to this, which is Fs. So that is your shear component, ठीक है जी? Now, as far as यहाँ पे if we look over here, तो देखें,
सर मुझे आवाज नहीं आ रही है सर.
maybe you have problem with the internet, because I can hear you very clearly, and I think the others can hear me also very clearly. Why don't you go back and join again? Huh? तिलक वापस लाड़ से बिया join का. अच्छा जी, so if we look here, देखिए, what is this length over here? देखिए, this is more as I come और if I draw lines, तो मेरे पास सबसे minimum जो thickness होगी वो कितनी हो सकती है? What will be the minimum thickness that I will have in here? कहाँ पे होगी? Or let's say if I draw a line over here, ठीक है जी, which is perpendicular to this, so I can see that now I have this triangle, ठीक है जी, and I can resolve this as I change, you know, this angle के यहाँ पे मैं हूँ, or if I'm over here, or if I'm over here, wherever I am, ठीक है जी. But I can find Fs and I can also find Fn. ठीक है जी. How would I do that? If I know the angle, ठीक है जी. If I know this angle, I can go ahead and calculate that. So I can say that my Fs is equal to F sine of theta. ठीक है जी. And similarly, I can have Fn as F cos theta. ठीक है जी. So these are going to be the two components that I have. ठीक है जी. Now, looking over here, I can also calculate this thickness T, which will be sine of 45 T over sine of, using the law of cosines, sine of T over sine of 45 H over sine of 180 minus 45 minus theta H over sine of 135, ठीक है जी, minus theta, और I can say कि ये जो T है मेरा, right, this T, which is this thickness, this is equal to H over cos of theta plus sine of theta, right? So it is either, it is going to be the thickness which we were taking for the area, that is this H over cos of theta plus sine of theta. Now, if we go further, so I can now find out the shear component, which is going to be the shear force divided by the area. So shear force मेरे पास क्या है? That is F sine of theta and divided by क्या? Divided by T times L. ठीक है जी. This is what we said that हमारा जो stress होगा वो ये होगा. Now what is the value of T? T is H over T हमारे पास क्या है? What is the value of T? T
H over cos theta plus sin theta.
H over cos theta plus sin theta. So incorporating this in this equation, we will get F over HL times sin theta cos theta plus sin square theta. ठीक है जी. Similarly, we can find out the normal stress, which will be equal to Fn over A, and that is putting the value of T in there, we will have F over HL cos square theta plus sin theta cos theta. ठीक है जी. Now we can go ahead and combine these two and find out the von Mises stresses, which will be the square of this plus 3 times the square of this under the root. ठीक है जी. तो ये हमारा बन जाएगा sigma dash. ठीक है जी. And putting the values in here, we can find out the von Mises stresses. Now, the thing here is that theoretically this does make sense, लेकिन And if we go ahead and find out the largest stresses using this one means stress stress, we can vary this angle. जैसे अभी मैंने कहा कि we can find out मतलब the stress in here and so on. ठीक है जी? So the largest stress would occur at 62.5 degree with a value of 2.16 F over HL. Similarly, the maximum जो हमारे पास shear stress है that occurs at 67.5 degrees with a value of tau equal to 1.207 F over HL. लेकिन looking at this and looking at experimental results, they do not match. It is kind of complex. So the analytical models or the models or the one that we just use, that does not approach accurately the experimental measured stress. उससे उसमें फर्क होता है. So what do we do? Here is we take a very conservative approach, and the conservative approach is let's assume that the external load is carried out entirely by the shear force on the minimum throat area. अच्छा, ये बताएं कि minimum throat area कहाँ पे होगा? ठीक है? If this is my joint, well, I will just do this. If this is my joint, ठीक है जी, ठीक है जी, and I weld this. तो इसको तो मैं when I weld it, it's going to look like this. ऐसे नजर आएगा, right? Okay. What I'm going to do is fill this out with the weld. If it is a fillet weld, ठीक है जी. So this is my weld now, right? But if I look at this, so again, looking at the reinforcement and all those, actually what I have here is, okay, I will have, if I do this, this is my edge, ठीक है? So it's going to come over here, and then like this, I'll form this triangle. ठीक है जी? Now, what is the minimum area that I will have? कौन सा area होगा? कोई बता सकता है?
सर इसी जॉइंट पे होगा सर वेल्ड के.
Yes, but where is it going to occur? देखें, ये जो reinforcement है ना, ये ऊपर चली गई है. It's not, this is not what I will have basically. बल्कि मेरे पास weldment में throughout I'll have a minimum area throughout, and that minimum area basically, if I take
Yes, sir.
an angle,
Perpendicular.
yes, if I draw this perpendicular,
Yes, sir.
then ये जो angle है, this turns out to be 45. ठीक है जी? तो basically ये this is going to go throughout the joint. ऐसे ये this is going to go throughout the length of the joint, and that is why if you look over here, I have this triangle where if this is 45, so it is F over 0.707 times of H. ठीक है जी? So I took this as 45, which is 0.707, what I'm assuming is that I'm just taking the minimum area now. ठीक है जी, तो 0.707 times HL, this is a very conservative model. What I'm saying here is that I'm not taking this whole thickness, balki the minimum, at least the minimum throat area that I can have, and that will be 0.707 times H times L. जी, ताबिश खान.
सर जब हम क्या कहते हैं ये जब आपने कहा लार्जेस्ट वैल्यूज लेते हैं तो तब क्या कहते हैं सर मसला होता है सर, जब हम कंजर्वेटिव अप्रोच करते हैं तब मसला होता है या नहीं?
जब हम बहुत कंजर्वेटिव हो जाते हैं तो एट दिस स्टेज देखें, अगर हमारा स्ट्रेस जो है उसकी प्रेडिक्टेड, इफ द प्रेडिक्टेड वैल्यू ऑफ द स्ट्रेस इज lower than the actual stress, so the consequences are more serious, that the weld will break, right? But if you take the area minimum and it is more than that minimum, so yes, there are consequences which are cost. It will cost you more. ठीक है जी, the weight will be more, but those are not as serious as failing of the part. ठीक है जी, so that is why what we are saying is that we are taking a very conservative approach, and we are saying that we are ignoring the normal stress on the throat, and we